How does a country with almost no rivers build futuristic cities in the middle of the desert and still have water? Saudi Arabia is home to one of the most arid environments on Earth. With minimal rainfall, no permanent rivers, and extreme temperatures, water scarcity has long defined life in the region. Yet today, modern cities are expanding across the desert, supported by a water supply that does not rely on natural freshwater sources. This transformation is the result of advanced engineering, technologies that convert seawater into drinking water, extract moisture from the air, and recycle every possible drop. This is the story of how Saudi Arabia is engineering water in the desert, and what it may reveal about the future of cities worldwide. Join us at Manatech Explorers for more insights into groundbreaking technology and innovation from around the world. In Saudi Arabia for generations, access to water has been limited and unpredictable, shaping settlement patterns, agriculture, and daily life. Traditional water sources such as underground aquifers are finite, and prolonged overuse has placed increasing strain on these reserves. At the same time, rapid population growth, urban expansion, and industrial development have significantly increased water demand. This creates a fundamental challenge. How can sustainable cities exist in an environment where water is naturally scarce? Water is the foundation of modern society, extending far beyond basic human consumption to support public health, agriculture, energy production, and economic development. In arid environments such as Saudi Arabia, water availability directly shapes the cities. Without water, economic stability and quality of life cannot be sustained, making water the single most critical resource for the nation's future. Desalination has emerged as a cornerstone of Saudi Arabia's ambitious water strategy, allowing the country to transform seawater into safe, drinkable water on a scale few other nations can match. In a region defined by extreme aridity and minimal natural freshwater sources, this technology has become not just an option but a necessity. Using advanced processes like reverse osmosis, desalination plants remove salt and impurities from seawater with remarkable efficiency, producing reliable, high-quality freshwater that sustains both cities and industries. The scale of these operations is staggering. Saudi Arabia now operates some of the largest and most technologically advanced desalination facilities in the world, providing millions of cubic meters of water every day to meet domestic, agricultural, and industrial needs. By turning the surrounding seas into a dependable water source, desalination has enabled the country to undertake large-scale urban development in the heart of the desert, supporting the growth of modern cities that might otherwise have been impossible. Cities like Riyadh, Jeddah, and the futuristic NEOM project rely heavily on these systems to maintain daily life and drive economic expansion. Yet, despite its transformative power, desalination alone is not a complete solution. The technology is energy-intensive and requires careful management to minimize environmental impacts, such as brine disposal and carbon emissions. Recognizing these limitations, Saudi engineers and planners began exploring complementary approaches to water production. Rather than relying solely on the sea, they looked skyward, harnessing technologies that extract moisture from the air itself. Atmospheric water generation, combined with smart recycling systems, represents the next frontier in ensuring a sustainable and resilient water supply. By integrating these solutions, Saudi Arabia is not merely coping with scarcity. It is redefining what is possible in one of the harshest environments on Earth, setting a model for innovation and resilience in water management for the world to follow. In addition to relying on desalination, Saudi Arabia is pioneering innovative technologies that extract water directly from the atmosphere, offering a remarkable solution to the challenges of desert living. Known as atmospheric water generation, these systems capture moisture that is naturally present in the air and convert it into clean, drinkable water through precise processes of cooling and condensation. By tapping into a resource that is often overlooked, the very air around us, these technologies provide an additional, reliable source of water in regions where traditional supplies are scarce or non-existent. What makes atmospheric water generation particularly valuable is its adaptability and decentralization. Unlike large-scale desalination plants, these systems can be deployed in remote towns, industrial sites, and even developing areas where access to piped water is limited. They operate efficiently in harsh, arid climates, producing water on demand and reducing dependence on conventional sources such as aquifers or transported water. Beyond practicality, this approach demonstrates a forward-thinking vision for sustainable water management. By harnessing the atmosphere, Saudi Arabia is not just supplementing its water supply, it is diversifying it, making it more resilient to the pressures of population growth, urban expansion, and climate change. These systems reflect a broader strategy in which technology and innovation are used to overcome environmental limitations, ensuring that even the driest regions can support thriving communities. In doing so, atmospheric water generation represents a critical step toward redefining what is possible in the world's most water-challenged landscapes. Smart water recycling has become an essential component of Saudi Arabia's comprehensive water management strategy, enabling the nation to make the most of every drop in an environment where water is scarce and highly valuable. At its core, this approach involves advanced treatment systems that safely purify wastewater, transforming it into reusable water suitable for domestic, industrial, and agricultural purposes. By doing so, these systems dramatically reduce water loss and ensure that urban and rural communities can continue to thrive even under the pressures of population growth and arid climate conditions. The effectiveness of smart water recycling is amplified through the integration of digital monitoring technologies and artificial intelligence. These systems provide real-time data on water usage, identify leaks or inefficiencies, and forecast demand across different sectors, allowing for optimized distribution and minimal waste. AI-driven management also supports predictive maintenance, ensuring that infrastructure operates efficiently and continuously, even under high-demand conditions. Moreover, the closed-loop nature of these recycling systems promotes a sustainable approach to water resources, creating a cycle in which used water is continually treated, reused, and reintegrated into the supply chain. This not only conserves natural freshwater sources but also reduces reliance on energy-intensive solutions such as desalination for certain applications. Beyond the technical benefits, smart water recycling reflects a broader commitment to innovation and environmental responsibility. By combining advanced treatment processes with intelligent monitoring and adaptive management, Saudi Arabia is setting a global example of how technology can address water scarcity in arid regions. Through these efforts, the country ensures that each drop is used to its fullest potential, reinforcing long-term sustainability and demonstrating a scalable model that other water-stressed regions around the world could emulate. Saudi Arabia's ambitious megaprojects, including NEOM and the Line, represent a bold vision for sustainable urban development in one of the harshest environments on Earth. These futuristic cities are not merely architectural achievements. They are living examples of how cutting-edge technology can be integrated into every aspect of urban planning to overcome the challenges of extreme aridity and limited natural resources. Central to their design is a comprehensive approach to water management, combining desalination, atmospheric water generation, and advanced recycling systems. By strategically coordinating these technologies, the cities are able to maintain a reliable and resilient water supply for residents, businesses, and public spaces. Water infrastructure in these projects is meticulously planned, often situated underground to minimize evaporation and reduce environmental impact. Renewable energy sources power key systems, while artificial intelligence continuously monitors water distribution, identifies inefficiencies, and ensures optimal usage. This combination of innovation and sustainability allows the cities to operate efficiently while conserving one of the most critical and scarce resources in the desert. NEOM and the Line also illustrate a broader reimagining of urban development. By prioritizing resource efficiency from the ground up, these projects demonstrate that large-scale urbanization can be achieved without overexploiting natural reserves. They offer a blueprint for resilient, technologically advanced cities capable of thriving under extreme conditions. Beyond Saudi Arabia, these initiatives provide valuable insights for the global community, highlighting how innovation, careful planning, and sustainable design can transform even the most challenging landscapes into vibrant, livable urban environments. Despite Saudi Arabia's significant advancements in water technology, the nation continues to face complex and ongoing challenges. Large-scale water production, particularly through desalination, is an energy-intensive process, requiring vast amounts of electricity to operate reverse osmosis and other treatment systems. Reliance on conventional energy sources can place additional strain on the country's energy infrastructure and contribute to carbon emissions, making sustainability a critical concern. Another pressing issue involves the management of byproducts. Desalination produces concentrated brine, a highly saline wastewater that, if discharged improperly, can disrupt marine ecosystems, harm biodiversity, and affect coastal fisheries. Ensuring environmentally responsible disposal or treatment of these byproducts is therefore essential to prevent long-term ecological damage. Beyond technological and environmental considerations, socioeconomic pressures add further complexity. Rapid urbanization, population growth, and expanding industrial activity continuously increase demand for water, often exceeding natural supply limits. Over-reliance on groundwater or surface water in certain areas can lead to depletion and reduced resilience in times of drought. Addressing these challenges requires an integrated approach that combines innovation, careful planning, and environmental stewardship. By balancing advanced technologies with sustainable practices, Saudi Arabia can continue to provide reliable water supplies while minimizing ecological impact and ensuring long-term resource security for its cities and communities. By 2050, billions of people around the world are projected to face severe water shortages, making access to reliable water a critical global challenge. In this context, the strategies Saudi Arabia is employing to secure water in its desert cities offer lessons that extend far beyond the kingdom's borders. Faced with extreme aridity and growing urban populations, the country has implemented a comprehensive and integrated approach that combines large-scale desalination, innovative atmospheric water generation, and advanced smart recycling systems. Together, these technologies create a diversified, resilient water supply capable of supporting both urban and industrial growth, even under the harshest conditions. Saudi Arabia's experience demonstrates that technological innovation, strategic planning, and sustainable practices can work in tandem to overcome seemingly insurmountable environmental limitations. By designing cities and water infrastructure from the ground up with efficiency and sustainability in mind, the country provides a model for other arid and water-stressed regions seeking long-term solutions. These efforts highlight the importance of combining resource management with environmental stewardship, ensuring that growth does not come at the expense of ecological balance. Ultimately, Saudi Arabia's approach offers valuable insights for policymakers, engineers, and urban planners worldwide, showing how innovation can address one of the most pressing challenges of the 21st century. Securing water for a growing and increasingly thirsty global population. In a land long defined by scarcity, Saudi Arabia is demonstrating that technology can challenge and even transform the limitations imposed by nature. Through a combination of advanced desalination, innovative atmospheric water generation, and smart recycling systems, the country is not merely coping with water shortages. It is reimagining how water can be sourced, managed, and conserved in one of the harshest environments on Earth. Water is being drawn from oceans, extracted directly from the air, and continuously reused and recycled, creating a sustainable cycle that supports thriving cities and ambitious megaprojects. The desert, once considered a barrier to growth and development, is now becoming a landscape of possibility and innovation, illustrating how human ingenuity can overcome environmental constraints. If you found this exploration insightful, we invite you to like, subscribe, and share your thoughts, Should other countries adopt Saudi Arabia's model for sustainable water management and urban development? Join us at Manatech Explorers for more insights into groundbreaking technology and innovation from around the world.